Lesson 2 of Chapter 3 of Probability and Statistics. Our topic today is density curves. Our essential outcome is that you will understand how to translate from a histogram into a density curve and know the properties. So, here, remember what a density curve is. It is a curve that describes overall pattern. It doesn't show individual detail. It's idealized perfect description of data. There are three types. There are skewed, where there's more data points. There's uniform, where it's completely distributed evenly, and there's normal density curves, which are symmetric. So the thing about density curves is each one has an area of 1, which means that it covers 100% of the data, and it's always above the x-axis. All right? And so we're going to draw some density curves and evaluate them. So here I have a density curve. It's a uniform distribution, we can see that. So the first thing we need to check is, does the area equal 1? So if we look at this, we treat it like a rectangle. So how long is the base? Well, the base right here is 2. All right. How tall is it? Well, it's 0.5 tall. So go 2 times 0.5. That equals 1. Check. It works. It covers 100% of the data then. So if we think about now the mean and the median of a uniform distribution, because it's uniform, it's symmetric, and so the mean and the median are always in the middle. And so if we look at the middle of this, it's the middle of this bar graph part. It's going to be right down the middle, right there. And so then our mean and our median would both be 2. It's as simple as that. And so when we find a uniform distribution, remember it's symmetric, the mean and the median are in the same spot, they're both in the middle. You always need to make sure that the area equals 1, 2. So if we're going to find the percent of observations between 1 and 1.5, we need to find the area between 1 and 1.5. So I'm going to draw in a rectangle showing that area. Well, here's 1 to 1.5. You can kind of shade that in a little bit. There we go. That's our area that we're dealing with in here. All right, so how tall is it? It's 0.5 tall. And how wide is it? It's 0.5 wide. So 0.5 times 0.5, that gives us 0.25 or 25%. If we think about that, we could that bar that we drew in there, this purple bar that we drew in here, we could fit 4 of them underneath that density curve. So yes, that works. All right, so we're going to draw a density curve of the outcomes of rolling a die. And so a die has 5 options, 1, 2, 3, 4, 5, and 6. And so if we think about it, each outcome is just as probable. And so we get a uniform density curve. It goes up to 1/6. It goes all the way over to 6. And there we have it. Let's double check that area is 1. We do 1/6 times 6. That gives us 1. So where would the mean and the median be in this curve? They're going to be in the middle. So the middle looks to be right there. So if we think about this, my initial reaction is to say that the mean is at 3. However, that would only work if you could roll a 0, which you can't. And so instead, the mean is going to be right in between this 3 and this 4. Right in between that is 3.5. And that's also the middle of the data, so the mean and the median are both 3.5. Our next question then is, what percentage of outcomes are from 2 to 5? So I'm going to draw a box here from 2 all the way over to 5. All right. So let's think about that. What are our possible outcomes then? Well, we can have a 2, we can have a 3, we can have a 4, and we can have a 5, and those will give us all of our outcomes. So if we're going to find the percentage of outcomes, it's going to be 4 out of the 6. If we do 4 divided by 6, we get 0.67. I rounded it, which gives us 67% of the outcomes are from 2 to 5. All right, so here we have 2 histograms. Remember, we can turn a histogram into a density curve with little to no work that we have to do. All we do is we drive a nice smooth curve that doesn't really show any individual data. And so if I follow this one, I kind of get something like this. It's a pretty nice density curve. Here we've got another nice density curve. If you notice, both of those are skewed a little bit to the right. And so if we have to draw in our mean and our median, okay, in the past we've had 3 lines in there. Here's one, there's usually about one here, and there's usually about one here. Now, remember we said that the mean is pulled more to the tail, and so this one that's pulled the most, that's going to be our mean, that's our x bar. And then our median is also pulled, that's going to be our line right there. And this third line is actually going to be our mode. We didn't talk about that before, but that's what that would be. So I'd like you to pause the video now and see if you can find the mean, the median, and maybe even the mode for that second graph. And there you have our average, our mean is right here, our median, and our mode. Alright, that was the end of density curves, lesson 2 of chapter 3. Remember to write your summary and your questions. The essential outcome for today is that you will understand how to translate from a histogram into a density curve and know the properties.